Hi, I'm John Rodriguez, a senior student from Universidad Técnica Federico Santa Maria, and I'm here to present my thesis topic. But first, let me put you in context real quick. The Large Hadron Collider, LHC at CERN, the European Organization for Nuclear Research, is the largest and most powerful particle accelerator. This huge collider consists of a 27-kilometer ring with superconducting magnets located underground between Switzerland and the border of France. Inside the LHC, bunches of protons collide at a frequency of 40 MHz, and each collision or event can produce huge amounts of particles that decay in complex ways as they pass through the layers of the LHC detectors. Atlas is one of the four main detectors of the LHC. It is 40 meters long, 25 meters high, and weighs around 7,000 tons. Atlas is designed to detect most of the particles produced in a proton-proton collision or event, due to its millions of sensors, specially designed to measure different properties of the particles, such as momentum, energy, electric charge, among others. The large amount of data produced per event is filtered using the Atlas trigger system, an essential component of any collider experiment, which has specialized algorithms to give only the interested events from the point of view of high-energy physics. The identification or classification of events stored by the trigger system is one of the most important tasks performed by the LHC scientific community, because it is fundamental for improving the current results and also for searching for new phenomena in the high-energy physics field. Raquel Pessoa, my guide teacher, and I are working on a project that we call Deep Learning Applied in the Classification of Events Generated at the Atlas Experiment, where we deal with the problem of classification of separating the desired signal from the background using deep learning techniques. Specifically, the signal that we want to classify is the boosted d Higgs decaying into BB tau particles. So during this video, I'm going to discuss our main goal, our specific goals, the planification, a synthesis of the problem, and a conclusion. The main goal is to design, implement, and validate a deep learning based algorithm that is going to classify event data generated in the Atlas experiment, to identify the production of a boosted d Higgs decaying into BB tau particles, taking into account the imbalance problem, the validation metrics, and the validation with the Atlas analysis system. Our specific goals are: first, we have forming a knowledge base in physics in the context of the Atlas experiment, check the machine learning state of the art concerning the Atlas experiment, analyze the class imbalance problem, generate a proper dataset using the computational tools of the Atlas experiment, validate using the standard metrics in machine learning and also the metrics used in high energy physics, validate the algorithm in the Atlas analysis system, and last but not least, define proper deep learning techniques that are going to help us to develop an algorithm to classify the boosted d Higgs from the background. The planification is going to be divided in 5 stages across the semester. First, between March and April, we're going to do a research in the state of the art to know what are the methods that are being used before to solve our problem or a similar problem. In April, we're going to choose some deep learning techniques. We're going to compare them and test them in some toy datasets to evaluate which one will be better for us. In May, we're going to generate our dataset and we're going to perform some preprocessing. Also, we're going to select the validation techniques which are going to be useful for evaluating our deep learning algorithm. Between June and July, we're going to train and validate or deep learning based algorithm and perform some modifications to the model if necessary. Finally, in the last stage between August and September, we're going to check the last details of the algorithms and the report. To wrap up this video and conclude, we're going to apply a deep learning based algorithm into the data generated at the Atlas experiment to classify them into a boosted d Higgs decaying into BB tau particles or just background. We're expecting improvements over the last technique used and also keep promoting the use of deep learning in high energy physics. To keep up with this project, you can subscribe to the channel and also follow me in my social medias. Thanks for watching. Bye bye. Thumbs up.
Sí.